So we're back again for our third segment with Sebastian. Now, Sebastian, I know that you've done a lot of research with convolutional neural networks. Can you tell us a little bit more about what they are? And I know our students are excited to hear about this too, because they're about to learn how to implement them.
Yeah, so convolutional neural networks are a very smart way to structure your network. And built in is what's called an invariance. So for example, if you take the idea of a scene recognition, you have an image in front of you and want to understand, is Sebastian in the image? It doesn't really matter whether my head is up here or down here or over there. The recognition of my head, my face, is the same no matter where you are. That invariance, this kind of location invariance, is hard-coded using convolutional neural networks. So you have a repetition in your network, a structured network that makes sure whatever you learn for the corner down here in the image works up here.
Excellent. And so can you tell us a little bit about some of the applications that you can see for CNNs?
People have used them massively for anything, image and video, including medical imaging. They're also being used now for language technologies, where people use deep learning for understanding and replicating language. And the applications are really limitless. They can use them in finance and many other fields.
I use them for satellite imagery.
Nice.
Yep, absolutely.
They're very common imagery, yes.
Yep. And then I guess another question I have would be, CNNs have been so important in your work, and you said that they have applications across all kinds of fields. Are they the last thing that we can expect to see out of deep learning, like the last big advance, or is there still
I've learned never to say never, right? So we're always going to find something interesting. There's all this fascinating work going on in adversarial deep learning. And I'm very certain that as we invent faster computers, you're going to find better algorithms.
So there's still work to be done.
Always.
Excellent. And we're training the next iteration of pioneers. So is there any final send-off that you want to give them before they start learning how to build their own CNNs?
Here's an interesting fact. So convolutional neural networks were invented in 1989. That's a long time ago. Most of you probably weren't even born at that time. Which means it's not the cleverness of your algorithm that makes the big difference. It's the data that makes the difference. And now we live in a world where data sets are plentiful. They're very, very large. And we can now emulate human intelligence functions using the data we have. So when you work on this, focus on finding the right data and applying it and see if you can make magic happen the same way we made magic happen when we solved skin cancer.
Excellent. So let's go make some magic happen.